To make a recording of this, so we are starting recording now. But the question at play here, I believe, was this thing about a river of whatever length. The river has some currents going at whatever speed, and the idea is that you have some point A and some point directly across B, as well as a point a bit down the line C. And there's just a couple of questions regarding well, just a couple different questions you can ask in a situation like this. I think one of the very first ones was if you initially aim your boat directly towards sea and do not change that bearing, where in the North Shore do you land? And I guess this is actually starting with part C, huh?
Well, I already did A and B,
Yeah, okay.
so I didn't send those.
Okay,
If
that's
you want
fine.
me to, I can if you like.
Uh, I guess it's either way is fine. But yeah, part C isn't too bad, right? It's just basically saying, okay, so if you're just pointing if in still water, you're pointing your boat uh so that it goes towards C. Uh, it's basically say first imagine doing this in still water, so you can figure out whatever angle theta that is, right? That's not going to be too bad, just because you know this distance right here from B to C, and you also know the distance right here. So you know that you know the speed at which you can row your boat, which
Are
we'll
you
just
trying
call
to?
what's up.
Sorry, are you trying to share a screen or you're just
Oh,
explaining
I
something?
am. I am. Sorry.
Okay,
Yeah.
yeah.
Let me fix that. How do I share my screen? Do do do. By the way, has this class continued to be relatively difficult?
I don't think it's been as hard as that 1 week.
Okay.
Everybody seems to be getting this one a little bit more than what they
Okie
had
dokie.
last. And
All right. So
we,
basically, they have some V. I don't know what are they calling it. They're calling it V like boat relative to the. Yeah, excuse me. V boat relative to the water. I guess I should use a smaller thing. Uh, right. V of the boat relative to the water. And the idea is okay. Just based on this velocity and this theta, you know that the the time it takes you to cross this entire thing, if we call this distance d, d is just going to be equal to v bw times sine theta times t, right? And this will let you solve for t. So then
for
there's
time,
sort of what's up?
for time.
Yeah, the time it takes you to get across, right? So then there's sort of like two horizontal components. There's the horizontal component from the boat, and there's sort of like horizontal distance traveled by the there's a horizontal distance traveled by the what do you call it, the river. So then you just sort of add these two up. So this thing is basically just turns into v of bw cosine theta times time, right? This is basically how far you would have traveled. Uh, this is basically how far you would have traveled if there was no current, right? And that should turn out to be exactly whatever BC is, right? This should be just equal to the distance between B and C. And then you also have to add in the horizontal river, and that's why you actually need the time here, because at that point it's just V of the river times time, and whatever this sum is should just be your answer. Does that make sense? It's basically like saying how far would you have gone if it was just from your boat, and then how much further would the river have carried you in that time. And the reason this works is because the distance across that, the velocity perpendicular to the direction of the river is not affected by the river current, right? So it's just whatever this thing is lets you tell how long it takes to get across. Make sense?
Mm-hmm. Yeah.
Okay. So then the next parts are where it actually gets kind of difficult, and you have to draw out these kind of slightly intricate diagrams. So they give us, what do they say for the problem? They say that right, to reach point, they basically say, what if you pointed yourself so that you were starting at point C from the get-go? Or I'm sorry, what are they saying? No, they're saying you want to reach point C. So your overall trajectory, like V of boat relative to the ground, is sort of pointing from A to C. And the issue is you don't know the direction of that vector, right? So excuse me, sorry, we know the direction, we don't know the magnitude of VBG which is basically the same as the vector from A to C, or at least in the same direction. So what else do we know? We do know velocity of the river relative to the ground. That's just the current. That's the 30 miles a minute or whatever. And the other thing that they're telling us is the velocity of the boat relative to the river, which is basically just the direction your boat is pointing times the speed at which you row, which is given to be like 100 miles a minute or whatever, meters a minute. Right? So it's sort of this funny situation where you know everything about VRG, you know everything about, you know the direction of one and then the magnitude of the other, but there are some gaps we need to fill in. So it's kind of a confusing situation, at least until you draw it out. And it sort of all becomes illuminated once you draw it out, hopefully. But I'm just going to sort of redraw it a little bit. So if this is A, and this is B, and this is C, you can sort of figure out the entire path is going to be given by this vector from A to C, right? This is the desired path that you're going to be traveling like in real space from the perspective of the ground. So this is going to give you the angle theta. And this angle theta is basically the this known direction right here. Yeah, it tells you because this is the velocity of the boat relative to the ground. This is basically saying, okay, we have a little triangle that looks like this. This is the velocity of the river with respect to the ground. It's perfectly horizontal. We have some angle right here that more or less corresponds to this vector, which is velocity of B relative to the ground, and we don't know its magnitude yet. And finally, we have velocity of boat relative to the river, which we know this magnitude because you know how strong you row, right? You know it's 100 meters a minute, but we're not exactly sure what direction this is. And if we could just figure out some more angles, we'd know everything. So, yeah. Does this diagram make sense so far?
Yeah.
Okay, that's good. So just to sort of reiterate, I don't know, maybe I'll just write, we know that this one is 100 miles a minute, just to reiterate that we know this length. We know this one as well. We know that this one is like, what, 30 miles a minute?
30, yeah.
Yeah. And then at this point, we're just playing around with angles until we can find everything we need. So I think the problem is essentially asking us for this angle right here that they're calling phi. They're asking for that angle, which is basically the heading your boat would have to sail, the direction your boat would have to point in. It would basically be, if it's the same as asking if you were doing the exact same direction, but with the river was still, that would be your trajectory, right? If yeah. Anyways, yeah. So at this point, we know this. We know some of these magnitudes. We know this angle. So what else do we know? Okay, let's get inside the triangle, because just from parallel transversal lines, we know that this angle right here has got to be theta, right? Because this is parallel to this horizontal, and this is just alternate interior angles. So from the law of sines, we know that 30 over, let's call this angle beta. I think it's like 30 over sine beta is equal to 100 over sine of theta. Right? I'm pretty sure that's just the law of sines. Sound good so far?
Yeah.
Yeah, so at this point we can solve for beta because we do know what theta is. If you recall, theta we can just get from the Pythagorean theorem because we know the distance here and we know the distance here. And as it so happens, we can, even though this triangle represents distances, the angle we find from that distance triangle is the same angle for the velocity triangle. Does that make sense? That's a little.
Can you repeat that again?
Yeah. This angle theta that we find here from the distance triangle, where this distance is BC and this distance right here is the length of the river.
Yeah. Okay.
This
So
angle
to find.
theta, we get it from the distance information, but it also describes the angle theta between this vector and horizontal. Right? So this is one of the subtle parts of the problem, is that we get the theta from the distance information, but it applies to velocity just as well. This is all to say we
You were
know what
saying
what's up?
something with using the Pythagorean theorem to get the angle.
Oh, not the Pythagorean theorem, but I guess arctan.
Okay.
Yeah, my bad. It's all the same, it's just trig. But yeah, at this point we know theta, we know 100, we know 30, so we can figure out what b is. And once we know theta and we know b, then phi is really easy, because the three of them have got to add up to 180. Right? So we know theta, we know beta, and we're solving for phi. We just set them equal to 180 degrees and solve for theta. Pretty easy, right?
Okay. Yeah.
Yeah. And the rest of the problem, it just sort of all falls in line from there. What else are they asking? How long will it take to cross the river? Well, yeah, that's just asking you to get the velocity vector, bg. Excuse me. We already have some information about its angle. Now we just need to get its magnitude. And I think we can grab that information from the law of sines. Sorry, or maybe the law of cosines. So looking at this triangle, we know theta, we know beta, so we also know this other angle called gamma. Let's just call it gamma.
Mm-hmm.
And using the law of sines, we get that VBG squared is equal to VBR squared plus VRG squared minus 2, I think it's like VBR, VRG, cosine gamma. Just look up whatever the law of cosines is in order to solve for VBG.
Okay.
Makes sense? I mean, at this point, you know all the angles of the triangle and you know 2 of its side lengths. You can definitely get the third one. Just look up the law of cosines.
Okay.
Which I think I've got it right here, but maybe I made a typo. But it should be pretty easy at that point, right?
Yeah. Yeah.
So once you know VBG, right, once you know the genuine magnitude for this thing, well, at this point, it should just be a simple, it's even simpler than kinematics, really. It's just asking you how long it takes to cross the river. So just figure out whatever component of VBG is in the, is in the perpendicular direction. And you can just get that from trig. Okay. And then what distance d as measured by an observer from the ground do you travel? Wow, I think that's even simpler. I think you would just need to use the Pythagorean theorem to find this length. And then, what else? What is the speed of your boat as measured by an observer standing on the riverbank? So I think that's just asking for the magnitude of VBG, which we already found. So yeah, that's basically all there is to that problem.
Okay. Sounds good.
Yeah, simple as that, right?
Yeah, that's all I really had.
Yeah, very good. It's a neat problem. It's been a very long time since I've looked at anything to do with relativity. Yeah, it's a lot of fun. Anyways, if you have right, you said that's all you had. All right. Well, good luck. And as always, if there are more questions, just ping me.
Okay.
All right. Have fun.